What is up, YouTube? High Tech Lab here. Today we are in the off-the-grid electrical room. I wanted to show you guys some of my progress. I got a bunch of labeling done. So as you can see, live bus bars do not touch. Placed throughout. All the red stickers you can see. I got these labeled. I'll show you that in a second. I have a label on the door. And if you open up my panel, you can see everything is labeled. Everything is labeled. And then I have these two inputs. So this one comes from the inverter through the transfer switch. This comes from the generator. I'll show you that all in a minute. Here's my split bus panel. Different labels on here. Got this all labeled. I still need the filler plates for in here, but that's coming. You can see. The number one thing, let me shut this door, that I want to show you is this control panel. So let me start here. This is in the off position. I ran out of label tape, otherwise I was going to label all this. This just shows 24 volts is active. This is for the automatic start. Right now it's in the off mode. This is the manual mode, and this is the automatic / manual mode. So when it's in the automatic mode, this light comes on to say that the unit can auto start. This is a timer, so right now it's programmed for 1 hour. So if we go ahead and hit start, it's going to go start counting down from an hour. This is showing that the generator was activated manually. This is showing that the generator, like it's got ignition power. Glow plugs start and 240 volts active. So what happened was that generator went ahead and started up, and now it's done trying to crank. And you will see shortly, if you listened, we went ahead and closed power from the generator, and now we've transferred power from the generator to power all of the loads. And here in a second, this battery charger is going to kick in. So it's doing its thing, charging the batteries, blah, 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 blah. And then when 1 hour runs out, it'll shut down and return to normal mode. Or we could go ahead and hit this generator stop button. It runs for a few more seconds. And then it shuts the generator off. Let me grab a screwdriver, and I'll show you guys inside. So here we go. This is the inside of the control panel to do everything shown already. We have, it's pretty complicated, but it's also pretty straightforward. These two relays are part of the manual start circuit. They pretty much use this time delay to latch each other shut. That then goes through this, which is a safety relay. If there's a fault, it disengages the start signal. And then once that start signal is good to go, it comes out of here and goes into this relay. This is the main generator start relay. And then we also have this relay here, which is the automatic start relay. They're just, this white wire right here is tied in with this white wire here, runs through and activates this relay. Once this relay closes, it gives the ignition power to the generator and triggers this relay, which is the glow plug relay. Once this relay goes through its time running the glow plugs, when it times out, it activates this relay, which cranks the generator. And it cranks until it starts, which then gets disengaged by this relay. It stops cranking. But if this time delay runs out, and this is activated by these two, which senses 230 volts from the generator. If it doesn't sense 230 volts and this relay runs out of time, it triggers this relay to go into fault mode. So pretty much it gives it's like turning the key to the run position, glow plug position, start position, and then we have it verifies the power here. This relay is just a disconnect for the generator. Let me try and remember what that one did. I don't remember what that one did. Oh, this was just to trigger the indicator light that it's in crank mode. So if the glow plug's light is up and the crank one is not, it's because this is negatively biased and this is positive bias. I couldn't go negative because it would have kept a constant light on for the crank light. These two were the 240 volts off the generator sensor, and these two and this one are running this contactor. That's my unloader contactor. So when the generator goes to shut off, these keep the generator running for another about 10 seconds, 5 to 10 seconds. But they take the load off before they shut the generator off, because it's bad to shut a generator off under load. Here's a 24 volt transformer, a 48 to 12 volts DC to DC converter. It's a battery equalizer, but it can, the way I have it tapped, it's used to go tap 12, 24, 36, and 48 volts. 12 volts goes to this inverter, which gives 120 volts to this interval timer right here. And then the inverter also gives 124 volt or 120 volts to this 24 volt AC transformer, which these contactors, I ordered DC contactors and they came out AC, unfortunately. So I have to have that special transformer just for these contactors. And then these two relays handle the transfer switch. These two are sense circuit for transfer switch to make sure that the power is on the line side, making it to here. As you can see, these are 60 amp contactors. So I want to show you guys, there's also a buzzer in here. I'm going to pull out this relay, and if you look, these 4 wires down here come up to the generator. Those are all the control wires. So without that relay, nothing goes out to the generator. So I'm going to go ahead and hit the start button, and you can see these 2 relays closed, these all closed. It's going through its glow plug timer, and now it's going to try and start, but since that relay is not in there, it won't. And then you'll see, once this is going to be loud if you're wearing headphones, but once that trips, it lights up that there's a fault, and to reset that fault you got to hit this button. And we're going to go ahead and stop the attempt to start, because if you don't hit stop before reset, it'll try starting again. So what that is if something's wrong with the generator, it didn't sense that there was 240 volts coming back, the system went into a fault mode. So it's got fail safes in case it tries to start automatically and whatever, and it fails. So it's all, you know, pretty well thought out, planned out. I'm going to come over here to my Outback Mate 3 and go to generator and do a manual start, but normally it's on automatic start. So I'm going to hit on, and that then lights up this light to show that it was activated automatically. And then I'll show you guys in here with these transfer switches. So now we have 240 volts coming through to here. So these are now doing their thing here shortly, and you'll see that relay contact fired. And then after it gives a delay on this time delay here, you'll see it let off on this one and transferred this one. Now this is interlocked, so if this relay is active, this one cannot be activated, and vice versa. And then I'll show you guys the shutdown process. First thing that happens is this unloader kicks in. Oh, I realized something just now. I had it start automatically. So let's go ahead and go off. First thing that happened was this unloaded the generator. Now this time delay is going, and now that it's up, it's shutting down. Now there's a little bit of flutter in these relays because the generator doesn't do a nice drop off on the voltage, but that doesn't matter because everything disengages before the generator goes to shut down. So yeah, that's about it, guys. If you have any questions, please leave them in the comments below. It's been quite a fun project, but if you want to see more like this, go ahead and hit the subscribe button This has been High Tech Lab. Thanks, and have a nice day. Bye-bye.